so let us define a total derivative. So if u is a function of x, y, z, and x, y, z are the functions of t, then I can say that the total derivative is denoted by du by dt, and it is equal to, so dou u by dou x into dx by dt plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt. So this is known as the total derivative. Now let us solve the first problem. So if u equals to tan inverse of y by x and x equal to this and y equal to this, here it is clear that so u is a function of x and y, and x and y both are the functions of t. So we can calculate du by dt using the above formula. So now let us calculate dx by dt, dy by dt, and dou u by dou x and dou u by dou y. So we have to calculate dx by dt, right? So what is the differentiation of e power t with respect to t? It is e power t minus the differentiation of e power minus t is e power minus t into the differentiation of minus t with respect to t, which is minus 1, right? So this is nothing but so e power t minus into minus plus e power minus t. And similarly dy by dt, so that is equal to the differentiation of e power t is e power t plus the differentiation of e power minus t is e power minus t into differentiation of minus t with respect to t, which is minus 1. So this is nothing but so e power t minus e power minus t. Now let us calculate the partial differentiation of u with respect to x. So while calculating the differentiation partially with respect to x, we have to treat y as constant. So the differentiation of tan inverse of function is 1 by 1 plus the function square, y by x whole square, into the differentiation of what? Into differentiation of the function, right? So here you can observe here y is constant, you can take that outside, and the differentiation of 1 by x is minus 1 by x square, right? So ultimately the final thing is it is 1 by, let us take the LCM here, x square is the LCM, the numerator is x square plus y square, and here it is minus y by x square. We can cancel this x square, so that the remaining thing is minus y by x square plus y square. So now let us calculate the partial differentiation of u with respect to y. So while doing that, x is constant here. Okay, so the differentiation of tan inverse of function is 1 by 1 plus the function square, right? It is y by x whole square into the differentiation of the function y by x with respect to y. So while doing that, x is constant, so here 1 by x is constant, take that outside, and the differentiation of y with respect to y is 1, right? So on taking LCM, this will become so x square plus y square divided by x square. In the numerator you have 1 by x, we can cancel 1 x here, and this x will go to the numerator, so the final thing is x by x square plus y square. So now we can substitute the values of dx by dt, dy by dt, and dou u by dou x and dou u by dou y. Okay, so the total derivative becomes, so now we can take x square plus y square common here. So now we can substitute the value of x and y. So here we can take minus common, so that it is e power t plus e power minus t into e power t plus e power minus t, which is e power t plus e power minus t whole square. So here we have e power t minus e power minus t whole square, which is e power t whole square, that is e power 2t, plus e power minus t whole square, that is e power minus 2t, minus 2 times e power t into e power minus t. So plus again e power 2t plus e power minus 2t plus 2 times e power t into e power minus t. So we can cancel this. So look at the numerator, this is a square and this is minus b square. So we know that a square minus b square equal to a plus b into a minus b. So here, so we can cancel this, right? So here we can cancel this. So the remaining thing is, so it is 2 into e power t into, so 2 into e power, so here e power t and minus e power t will get cancelled, so minus e power minus t minus e power minus t, which is minus 2 times e power minus t. So whole divided by, so I can take 2 common here, it is e power 2t plus e power minus 2t, right? I can cancel 1 2 here, so that it is equal to, so it's minus 2 times e power t and e power minus t divided by, it is e power 2t plus e power minus 2t. So e power t minus t is 0, which is 1, so it is minus 2 by e power 2t plus e power minus 2t. So this is the total derivative.